I'm Dr.S.Geetha, Assistant Professor, Department of Chemistry. I'm going to discuss about chemical bonding. Introduction about chemical bond. The force that holds two or more atoms together is called chemical bond. In other words, it is the attraction between positive nucleus and their negative electrons. So there are three types of chemical bonds. One is ionic bond, and next is metallic bond, and another one is covalent bond. Now I am going to discuss about ionic bonding. It is the reaction between a metal and a non-metal wherein the cation transfers its valence electrons to the anion due to electrostatic force in order to make it stable. It can be explained by taking an example of sodium chloride. First diagram in the left side is for sodium. Atomic number of sodium is 11. So K shell contains 2 electrons, L shell contains 8 electrons, and M shell contains 1 electron. And next diagram in the right side is for chlorine. Atomic number is 17. And we can see that K shell contains 2 electrons and L shell contains 8 electrons and M shell contains 7 electrons. Here, sodium would like to lose 1 electron for a full shell and chlorine would like to gain 1 electron for a full shell. Hence, sodium becomes Na plus and Cl becomes Cl minus, and they combine together and form a sodium chloride. Metallic bonding. It is the bonding between metallic elements in which the valence electrons can move freely from one atom to another. Since they can move freely, they are called delocalized electrons. They do not share, lose or gain electrons. These valence electrons form a sea of electrons. The properties. It has high melting and boiling points and it is a good conductor of heat. Examples of metal elements are lithium, magnesium and sodium. In this diagram, we can see that valence electrons move freely from one atom to another and form a sea of delocalized electrons. Now, I am going to discuss about covalent bonding. Covalent bonding is the result of chemical bonding of elements that share pairs of valence electrons. These bonds are usually formed between non-metal elements. There are three types of covalent bonds: single bond, double bond and triple bond. Single bond. It is formed when two atoms bond and share a single pair of electrons. Double bond. Here, two electron pairs are shared between two atoms and hence each atom contributes 2 electrons to the bond. Next, triple bond. Here, 3 electron pairs are shared between two atoms. Single covalent bond. Each atom shares one pair of electrons and each atom shares 2 electrons, and it is the longest bond and weakest bond of the three. In the picture, that is formation of hydrogen molecule, we can see that each hydrogen atom shares 2 electrons. Double covalent bond. In a double bond, each atom shares 2 pairs of electrons. That is, each atom shares 4 electrons. It is medium length bond and medium strength bond. example, you can see that the formation of oxygen molecule. Triple covalent bond. In triple covalent bond, each atom shares 3 pairs of electrons and each atom shares 6 electrons, and it is the shortest and strongest bond. Carbon, nitrogen, oxygen and sulfur can form double and triple covalent bonds. Strength of covalent bond. It depends upon several factors. So first one, number of shared electrons. The more electrons are shared, greater the bond. Next factor is the size of the atom. And next is the bond length. The greater the bond length, the weaker the bond. Sigma bond. A covalent bond formed by the overlap of orbitals along the bond axis, end to end. And it can be formed by the overlap of s and p orbitals, two p orbitals, two s orbitals, two hybrid orbitals, and s orbital and a hybrid orbital. Sigma bond formation. In the diagram, we can see that 1s orbital of hydrogen combines with another 1s orbital of another hydrogen and forms H2 molecule. That is, sigma bond is formed. Next, we can see that 1s orbital of hydrogen combines with 2p orbital of fluorine and forms hydrogen fluoride. Here also sigma bond is formed. Next, 2p orbital of fluorine combines with 2p orbital of another fluorine atom and form F2. Here also sigma bond is formed. Pi bond. In the picture, we can see that pi bond is formed by the side-by-side overlap of two p orbitals. Now we will see the differences between sigma and pi bond. Sigma bond, pi bond. Sigma bond is formed by the axial overlap of the atomic orbitals. Pi bond is formed by the sidewise overlap of atomic orbitals. The overlap is large and a strong bond is formed in sigma bond, and the overlap is small and weak bond is formed in pi bond. All the s orbitals and only one lobe of p orbital is involved in overlapping in sigma bond. S orbital do not take part in bond formation, while both lobes of p orbital take part in overlapping in pi orbital. In sigma bonding, the electron cloud is symmetrical about the internuclear axis, but in pi bond, the electron cloud is unsymmetrical. So the sigma bond can also be formed in the absence of pi bond. The pi bond cannot be formed in the absence of sigma bond. And free rotation about sigma bond is possible in sigma bond, and free rotation of the atoms around pi bond is not possible. We therefore conclude that there are three types of chemical bond, which are ionic, metallic and covalent. Ionic transfer of electrons between non-metal and metal. Metallic is the bond between metal elements in which electrons are delocalized, while covalent is the sharing of pairs of electrons. Thank you.